Hello, welcome, chemistry scholars. So today we are going to finalize our single proportions ionic bonding. Hopefully you did your homework that we assigned you from yesterday. Always want to start off with a chemistry joke. Never trust an atom. They make up everything. It is true. Absolutely everything. All right, so quick review. Make sure you have your periodic table out, and also make sure that you have a notebook out so that you can take notes. The video, we're gonna definitely stop the video a few times to make sure that you are writing down and you're trying the work on your own first. Okay, so make sure you have your periodic table out. Here's my periodic table labeled with the valence electrons. Remember that the metals are on the left side of the periodic table, non-metals are on the right. In ionic bonds, you're always bonding a metal to a non-metal. All right, so this was the first one that you had for homework. I wanted you to bond calcium with tellurium. If you were not able to do your homework, I want you to pause the video right now and I want you to try it on your own. Okay, so the first thing, metal, that's going to be calcium because it's on the left side of the periodic table. So we're going to go ahead and label that. Okay, so calcium is our metal. Our non-metal is going to be tellurium, Te. It is on the left side of our periodic table. All right, and now we are going to show the bonding. Okay, so we're going to show the bonding between calcium and tellurium. Calcium has 2 valence electrons. Remember, calcium is a metal, so it wants to lose these electrons. Metals are losers. Okay, metals are losers, so we're going to move these electrons into tellurium. Tellurium wants to have 8 valence electrons to complete its octet rule, so it's going to gain these 2 electrons, and we're going to make those X's, so that indicates that those electrons came from a different element. It's important that the original dots, the Lewis dot structures that you have, those are going to be regular dots, and then the ones that transfer in, make sure that you're putting those as X's. You will lose points if you don't have those as X's. All right, so we have 2 electrons transferred into tellurium. Now, calcium, what is our charge on calcium if it loses 2 electrons? Okay, our charge, remember when you lose electrons, it actually becomes more positive. This is sometimes a little counterintuitive. So I really tell students, when you lose electrons, okay, think of it becoming positive. So you kind of have to think lose positive. All right, this means you have 2 more protons than electrons. So that's where we're getting that positive charge from. Okay, so now we have a +2. So we're going to put our charge on calcium. Okay, and then we have tellurium. I'm going to make sure all of these transferred electrons, make sure I put all of those in the brackets. Okay, and then my charge on tellurium, it gained 2 electrons, so it's becoming even more negative. Okay, it's because electrons are negative, so that's how we're going to get a -2 charge. Okay, now my formula, it's going to be a 1-to-1 ratio. So I have 1 calcium to 1 tellurium. Next week, we're going to be working on different ratios of elements. So we're going to have 2 of one element bonding with 1 of another. Okay, so that's going to be pretty fun. All right, so we have calcium bonded to tellurium. So our formula is going to be CaTe. Remember that first letter is always capitalized and that second letter is always lowercase. That's extremely important. All right, we're going to balance our charges. The charges have to equal 0. Okay, our charges have to equal 0. So I have a +2 on my cation. And then I have a -2 on my anion. And this is a perfectly balanced compound with a charge of 0. So I hope that's what you guys got for your homework. Great job if you did. If not, keep trying. When we make mistakes, that's how we learn, guys. I want you to make mistakes. I want you to keep trying. So the more mistakes you make, the more you learn. All right, now the next one, this is the other one that you had for homework. So we have gallium reacting with nitrogen. Again, if you didn't have a chance to do it, go ahead and pause the video now and make sure that you're trying to work it out on your own. That's how you're gonna learn the most if you do it on your own. All right, we have gallium reacting with nitrogen. Gallium is gonna be our metal. It's on the left side of the periodic table. Okay, so we're gonna put gallium, and then nitrogen is our nonmetal. So gallium has 3 valence electron. It is our metal, so metals are losers. So it's gonna go ahead and lose these 3 electrons. I'm gonna do my arrows and my X's. Okay, so these X's are gonna be the electrons that got transferred in. Hopefully by now, this is about our 3rd video doing the single proportion bonding. So I hope you guys are starting to feel really confident in your bonding skills right now. So we lost these 3 valence electrons. So when I lose electrons, it's gonna become more positive. I did a review video yesterday with you guys to make sure that we really understand why these charges, okay, when you lose 3 electrons, you know that you have 3 more protons in that atom than you do electrons. That's what's gonna cause that atom to be a +3. All right, nitrogen is stable and happy. It has 8 valence electrons. It gained 3 electrons, so it gained 3 more negatives. So we're gonna put a -3 here. All right. And okay, my formula, I have a 1-to-1 ratio. All right, and my formula is going to be GAN. Okay, now I need to balance the charges. There's something I missed right now. I want you guys to think about the thing that I messed up on. Think about it in your mind, okay? Think about what did I miss when I was doing these bonding. There's something that I'm missing, okay? And if I miss that, I'm gonna miss some points on my quizzes, all right? Look at my bonding and see what I missed. Okay, so +3 -3, and I'm gonna have a stable compound. I hope you saw what I missed. Uh-oh, I see what I missed. I see that I missed these X's. I didn't represent my transferred in electrons, so I need to make sure I put my X's to indicate that this is a stable and happy atom now. All right, now, okay, now that is all correct. Okay, so check your homework. I hope that's what you got. All right, and the next one, we're gonna do one more. We're gonna do the sodium and the chlorine. I want you guys to pause, and I want you guys to do this one again on your own. So sodium, once again, it's on the left side of the periodic table, so that's gonna be our metal. And then our non-metal is gonna be chlorine. Okay, and then we have sodium has 1 valence electrons. It's our metal, so we're gonna lose that electron to chlorine. Sodium doesn't have, it lost all of its electrons, so it doesn't have any dots around it. That's also a common mistake for students, okay? And when it loses an electron, it's gonna become more positive. So now I have a +1 charge. And chlorine gained that electron. So I got to make sure I put this X in here to indicate that that electron got transferred in. And then it gained an electron, so it's going to be a -1 charge. My formula, it's going to be a 1-to-1 ratio. And I'm going to end up with NaCl. Okay, NaCl is actually table salt, okay? So this is what you guys put on your French fries. It's super, super delicious, okay? So this is the compound for sodium chloride, and it's what we use for our food all the time. All right, our charges, we have a +1, -1. Oh, it's a huge plus sign. Okay. +1, -1. And we are balanced and stable. We have a happy compound. Okay, great job. I hope that's what you got. Now, you guys should feel super, super confident about the one-to-one ratios. Now, I'm going to throw something new at you. This is really what we're going to be working on next week. So this is a challenge. Okay, next week we will do different ratios of elements bonding. So pause right now, and I want you to see if you can do it on your own. Okay, so we have 2 potassium reacts with oxygen. So the metal is going to be our potassium. It's on the left side of the periodic table. The non-metal is going to be our oxygen. Okay, so I have these 2 potassium and I have oxygen wants to gain 2 electrons. So I know that the metal is always going to lose the electron to the non-metal. So now I can see, okay, that one fits in here because remember, all the single ladies, which is your single electrons, they want to pair up with the other single ladies on the other element and go out dancing. So I want you guys to remember about the song, all the single ladies, all the single ladies. Okay, so now, okay, we can have our X's transferred in. Okay, so this is the beginning of what we're going to really do next week. We're going to get into these and you guys are going to be able to do these on your own and feel really confident with them. So both those potassiums lost an electron, so both of them have a +1 charge on them. And then the oxygen gained both the electrons from them. Okay, so now that's going to be a -2 charge. All right, so the formula, now this is where it gets a little fun. With the formula, I have 2-to-1 ratio. So I have 2 potassiums, okay, to 1 oxygen. Now, how we indicate that we have 2 potassiums in a chemical formula is we're going to put the K, and then at the bottom, it's called a subscript. It's like a little number. So I'm going to put a little bitty 2 down here, and that's an indicator that I have 2 potassiums. I'm sure you guys have seen this before, especially with H2O. Everybody's seen the formula with H2O. So this is very similar to that. So I have K2O now, okay, potassium oxide. All right, so my balancing my charges, now I have to balance 3 charges. So I have a +1, +1, and then a -2. All right, and my final balance. This is a fantastic compound, totally balanced, stable, and happy. So look forward to doing a bunch of those, okay, in the next videos. All right, great job, and hope to see you soon.